What I am proposing is exclusively an upgrade to your quality of life. There are no downsides. It's like smoking cigarettes. You'll get better at fantasy football, and at the same time, you'll learn some basic skills in Python programming, machine learning, and data science. Skills that you can use to do whatever. I mean, literally whatever. I don't care. I'm not your fucking dad. I'm not going to tell you what to do. Anyway, you are here. You are locked in. Let's get started. This is the getting started video. We're going to install Python. We're going to get familiar with Jupyter notebooks. We're going to get some data from Pro Football Reference. Then we are going to load it into the notebook, do some basic calculations and manipulation. We will be getting the yards from scrimmage stats for the 2024 season in the NFL, and then calculating fantasy points for each player. So like I said, the first thing that we want to do is install Python. There's a couple ways of doing that, and I will show you one of them. This is not what I am telling you to do. I'm just showing. If you were to want to install the default Python, you would go to python.org, then there's this drop down, downloads, Python 3.13, currently 0.5 is our version. That's not what we're going to do though, because there is a version of Python available at anaconda.com that is more appropriate for a data science use case. It's going to come with certain tools that are well suited to a data science workflow. So anaconda.com, hit free download. Here you can skip registration. If you would like to register, you can do that as well. Then it will bring you to this download now page. You have distribution installers and Miniconda installers. Distribution refers to a full Anaconda distribution. So the Anaconda version of Python. Miniconda is a stripped down version. There is definite benefit to the full Anaconda installation, but it just has so much bloat that I don't feel like I can recommend it even for a beginner. We are going to go with Miniconda and do some of the configuration ourselves that Anaconda would handle for us. So I'm on a Windows machine. I will hit that 64-bit graphical installer. Once that downloads, I will open it up and run it. So can hit next. I agree. You could, in theory, install this for all users. I would stick with recommended, but do whatever you want. If you change this, you better have a really good reason. So this page. Definitely register your Miniconda 3 as your default Python 3.13. Clear the package cache upon completion is fine as well. The top one, add Miniconda 3 to my path environment variable. I would not. This used to be the standard. Best practices have evolved in the Python ecosystem. It is no longer recommended to add your installation to your path. If you opt to check this box, you need to know exactly what you're doing because you can end up causing problems later. You'll hit install. This will take a few minutes. You can spend that time contemplating the insignificance of your life. So eventually it completes. Hit next. We don't need either of these checked because we don't care where they take us. Now what we are going to want to do is open a program called Miniconda prompt. Oh shit, I'm stupid. It's called the Anaconda prompt. So Anaconda prompt. So once this is open, we're going to use it to install a Python package. A package is a collection of pre-written code that the authors have made available for others to use, so you can download them, bring them into your code, and avoid having to rewrite certain functionality from scratch. The default way to install packages in Python is with a tool called pip. So if, for example, I wanted to install Jupyter Lab via pip, I would type pip install Jupyter Lab. That's not what we're going to do, because our Miniconda installation did install Python, but it also installed a tool called Conda, which is a package managing tool that works similar to pip, but it allows you to install non-Python code. So it can be useful for managing environments in maybe other languages like R or I assume Julia, or just Pythonic dependencies that don't rely on just Python. I'm getting kind of into the weeds. You don't really need to know too much about all of this. Just know that we are using a tool called Conda for installing packages. So you'll type Conda install Jupyter Lab, and note that there is a Y in Jupyter Lab instead of an I. So hit enter to run that. I'll hit A here, A here, A here. Then you'll hit Y, and you hit enter after each of those key presses. So we've installed Jupyter Lab. That's great. What I'm going to say now is X out of the Anaconda prompt. We are going to just immediately reopen it, but the reason I want you to X out is so that you can sort of disassociate that command we just ran from the next one. That command that we just ran, we will not need to run again. That is now installed in this Python installation. We are going to reopen that Anaconda prompt, and now we want to use it to launch Jupyter Lab. So every time you want to get into a Jupyter notebook, you are going to open the Anaconda prompt. You are going to type Jupyter Lab with a space this time. Again, remember there's a Y instead of an I, and then this time there's a space between Jupyter and Lab. So it starts doing stuff. You look like a hacker. It is going to open your web browser eventually. All right, we are now looking at Jupyter Lab. So no, I do not want to get notified about official Jupyter news. First thing that I'm going to do, because I'm not a barbarian, is set dark mode. Now, if you look in the navigation pane, I would call it file browser. If you look in the file browser here, you can note that these are your personal files inside your user folder, right? These are the subfolders in your user folder. With this being a Windows 11 clean environment, I have basically nothing in here. I don't know how most developers do this, but personally, I put all of my projects in a projects folder in my user directory. So then I would create that folder, create another folder in it for this specific project, which we can call ML4FF, Machine Learning for Fantasy Football, or MILF. So create that one, open it. Underneath Notebook, hit Python 3. That'll create a Jupyter Notebook from which you can run Python code. Again, a Jupyter Notebook is a very unique way of running code. If I create a traditional Python file, and I'm not really going to put actual code in here. I'm just going to say this is a call to some function. This is a call to a different function. And this is yet another function. If I were to then run this file, this Python file, it would run all three functions in this order and do nothing else. And there's no way to change that without changing the structure of the file itself. Notebooks, on the other hand, allow for a much more plug-and-play building block style of running code and of writing code. And that, I understand, is going to be very abstract and not something that you can fully grasp at the moment, but you will see what I'm talking about. So I will delete that fake Python file. What we need now is data. So like I said, we want the 2024 scrimmage stats from Pro Football Reference. And look at that. I have already looked it up. So 2024 scrimmage stats, scrimmage yards rather, PFR. And it was just the top result for me here. There is a mechanism through which you can use the URL to access the data, right? There are libraries, packages in Python that you can use to essentially plug in a URL and pull back the table of data. We're not going to do that right now. That is a little more advanced. That is a future video. What we're going to do is come to this page. We're going to hit share and export over here on the left side, and then we're going to hit get table as CSV. So when using sports reference data, please cite us and provide a link and or a mention. Look at that. It's a mention. So we're going to copy the whole thing here. And I suppose I ought to explain. A CSV comma separated values. It is a way of representing data in a, I guess I would say a spreadsheet-like fashion. Every row is separated by a new line, and every value in a row is separated by a comma. So if you look, right, Josh Jacobs is ranked 6, and then he is 26 years old, team Green Bay. So we will copy all of that data. We will bring it back to our Jupyter Lab. And I'm going to hit F11 to go full screen. Here we will want to create a new file. We can paste the data in. And then we can rename the file as a CSV. And in fact, we'll give it a good descriptive name, 2024 scrimmage stats.csv. And then when we open it, it lets us view it a little bit differently, right? Now it is in a traditional spreadsheet format. And so that's something that we can, I don't know, just visually inspect. You'll notice right away that the columns, right, are these categories: receiving, rushing, and ultimately scrimmage. But realistically, we can look at this and understand that the actual column titles are actually here in this first row. So that is one thing that we are going to have to deal with in cleaning up this data, and that's a great place to start. In a Jupyter notebook, you run code in what are called cells, like this one. I can print hello world. Then you can hit this play button, or you can hit Shift Enter. That will run the cell. So if you've never written Python code before, congratulations, now you have. When working with CSV data in Python, you want to read it into what is called a data frame. It is essentially a spreadsheet in code format. So rather than something like Excel or a table in a database. So the primary library or package, those terms are interchangeable. The primary library in Python for interacting with data frames is Pandas. It has been around forever. Everyone uses it. Everyone knows it. Virtually every data tutorial you come across is going to use Python as the data frames handler, so to speak. It is not the only name in town, nor is it the best name in town, but it is so ubiquitous that it would be reckless of me to point you toward another data frame package right now. Eventually, in some of these videos, we will almost certainly end up using polars because that is what I use almost exclusively, but Pandas is something that you need to know to work with data. Just that is what the ecosystem relies on. So we are going to install Pandas, and we are going to do it in a way that is not totally dissimilar from how we installed Jupyter Lab. Rather than doing it from the terminal, we're going to do it right here in the notebook. So you can hit the %sign. That will allow you to run what would normally be a terminal command here in a notebook. You could also use an exclamation point instead of the %sign. We will go with the %sign. So we'll do conda install pandas. When that finishes, you will get kind of an output here of, I don't know, what it did, what it installed. Regardless, Pandas is now available for us to use. In order to do that, we have to import it. So the syntax for importing something would be import, and then whatever it is that you want to import, in this case, pandas. Now, there is a caveat here because we have just imported pandas, but not in a way that pandas is typically imported or ever imported, right? So with the way we have imported it, to create a data frame like we talked about earlier, you would type pandas.dataframe, open parenthesis, you would have some data in here. Don't worry about what I am putting in here right now because it does not matter. That would be the data frame that I just created. You will be using things from pandas very often, meaning if you import it like this, you will be typing out pandas very often. You can save yourself some keystrokes by instead using what is essentially an alias, typing import pandas as PD, and then if you run that cell again, you can then replace pandas here with pd.dataframe, right? So now that did the exact same thing, but with fewer characters. I have never seen pandas used as anything but PD. I've never seen someone not use the PD alias. It is the broadly accepted way of importing and using pandas. Now that we have pandas installed, we can read in our scrimmage stats CSV as a data frame. So data frame is typically abbreviated as DF. DF gets PD, right? Pandas dot, and the function that we're going to use here is called read CSV. Very straightforward. We are reading a CSV. You'll do an open parenthesis inside of which you will put the name of the file that we want to read in single quote or double quotes. It doesn't matter. I always use single quotes, just a matter of preference, not meaningful. So I'll do single quotes, 2024 scrimmage stats. It is case sensitive .csv. Then I'll put the closing quote. And then in a cell, if you want to see the output of, or if you want to display something, you will just put it at the end of the cell. So if I run the cell like this, it will output nothing. It will perform that operation, and I will now be able to access that DF for display, but this cell where I read in the CSV itself does not display anything. However, I can put DF at the end. That will display the data frame, and there is a convenient function here for the data frame that lets us see just a few rows to examine sort of the structure of what we've read in without having to pollute our notebook with all of what is printed. So if I just use this df.head, it will only show me the first 5 rows unless I specify how many rows I want printed. So we'll go with df.head. We can see that much like we saw in the spreadsheet view here, we are getting our first row is actually the names of the columns, and the columns are these broad column categories. So that is the first thing we are going to fix. And to do that, we have to change how the data is read. So right now it is treating the first row in the file, the very first row that it reads in, and well, do I still have Pro Football Reference open? No, but that's okay. If I come back to the stats to demonstrate what I am talking about here, if you look at the data that we pasted in, you see how this first row is these categories, and before that it's even just empty values separated by commas. What we want to do is treat that first row as a row of data. By default, pandas will read in data treating the first row as column names. That is not the functionality that we want. So I believe the way to do that is to pass this argument here, header gets false. It is true by default. If you don't pass anything, it will treat it as true. If you pass it as false, it will read in data as if there are no column names. I might be wrong. It might be a different syntax. I'm wrong. Passing a bool to header is invalid. A bool is true or false. Passing true or false to header is invalid. Sort of for Boolean, basically just a value that is used to say whether or not something is true or false. You know, I guess it isn't more complicated than that. I instead want to be using header is none. So, oops, I got rid of my, okay, so that worked. It now read in those column names as the first row of data, and the columns are now just numbers. That is what we want. We can work with that. So what we want to do is separate the data frame into 2 different sections. We want one section that is just the column name rows. So just these first 2 rows, we're going to put in its own data frame. The rest of the rows, all of the player data, we're going to put in a different data frame. If you want, you can spend a second thinking about how we could extract just these first 2 rows. I will give you a hint. We have already used this tool. You can even see it on the screen right now. Otherwise, I'm just going to go ahead and do it and say column names df gets. We have our original df, our original data frame, dot head 2. So column names df, just so I can see what it is, right? So that is just the head of that original data frame, just the top 2 rows. What we're going to do is we're going to make the column names using these 2 rows, right? We can't use just the values in this row because, for example, receiving is a needed discriminator for yards. Otherwise, we would have a column for yards referring to receiving yards, another column for yards referring to rushing yards, and a third referring to scrimmage yards, all of which would be called yards. Pandas would not allow that. It would be something you could not work with. So we are going to iterate through each column. So this column 0, we will join the 2 values in that column, and then we will treat that joined value as that column's name. And that is the first thing that we're going to do. So for example, receiving yards, rushing yards per attempt, rushing yards per game. Those will be our column names. So we'll do this with a for loop. So for column in column names df dot columns, and to show you what column names df dot columns looks like, I will just print column. What this is going to do is it's going to print the column name for each column in the data frame. You can take a second to look at the data frame here to see what the column names appear to be, just to test your understanding. I'm going to go ahead and run it. And I sure hope you had the numbers 0 through 34, because that is the answer. But we're going to change that. So what we want is, how do we want to handle this? So using each of these numbers, we can access the values in the column with that name. So for example, if I want to print, actually, you know what? For the sake of simplicity, I will put column values as its own variable. I will say column names df, and then inside of square brackets, I will put the column. Remember, that's the name. And then I will print column values. So this prints just 2 values for each column, and it's the 2 values in each column. So first it's nan rank, nan player, nan age, nan team, and so on and so forth. What we can do now is join them using a function called join. And I don't know if this is going to work because I don't necessarily know what kind of things I can put into this join function. But if it does work, what it's going to do is it's going to join everything in here separated by a space. I put a space here, dot join, and then put our column data into the join function. Yeah, I didn't think that would work. Oh, but it broke for totally not the reason that I expected. Okay, that's fine. Then I'm going to come back to this column names df column. And what I'm going to do, essentially what happened here is that join function expects to receive what are called strings. They are just assortments of characters that, like words or anything you put inside quotes, basically. It can't be used as even if it is a number, it won't be used as a number. It will be seen as the same as if you had letters or whatever. A string is one of the many forms that data can take. It is one of the most basic, so it is what is called a primitive. In Python, there are 4 primitives. It is string, bool, which we talked about earlier, true or false. There are integers, which you should be familiar with what an integer is. If not, it is just a whole number. And then there are floats, which is any kind of decimal. Our problem right now is that that join function that I tried to use expects to receive strings, but I passed it a float, which is not technically true and it's kind of complicated. But what's happening is NaN here stands for not a number. Sometimes when certain operations are expecting numbers and don't receive them, they will replace it with this not a number. Typically will get treated like a float. So what happened here is the join function is expecting a string, but it receives not a number, which is treated like a float. It may look like a string because it's a series of characters, a series of letters, but it is not. So it's reasonably easy to get around that by just converting everything into a string. So at the end of our column names df column, which is again our column values, we'll put dot as type, and then we will just put str, which is string in Python. If I print it, things should look the same as they did last time I printed it. But now I can do a column name gets that space dot join column values. And then if I print the column name, it looks pretty good, right? Of course, we're not going to want this column, for example, to be named Nan rank. We don't want Nan player. So that's something else that we'll have to change. What we can do is use a replace. So we can assign column name again to be the same thing. Column name gets column name dot replace. And then we will plug in that Nan space, because note, after each of those Nans, there is a space. We will put a comma, and then we will put nothing. We will just replace it with an empty string. And so that had the effect we were hoping for. It's important to observe that if any of these first words ended with NAN, it would have created a problem for us, right? If this ended with Nan, it would have removed the Nan space and it would just say scrim touch. That would be an issue. So that's something to be cognizant of when using the replace function. It works fine in this specific instance. So we now need to store these column names. And to do that, we're going to create what's called a list, which is like a collection of objects. So we are going to say column names. And I get that some of these similar variable names might start getting a little confusing. I'm trying to just give things very literal names that represent what they are. You'll pick it up. So we're going to call this column names, right? This is just our list of column names. And there's two ways of creating a list in Python. We can put open square bracket, close square bracket. That's typically the more common way that you'll see it. You can also put list. For the sake of clarity, for the sake of your understanding, I'm going to do it like this time. I might switch in the future. We will see. In order to add our column names to this list, we will use a function called append. So we will take our column names list, we will do dot append, and then we will append the column name. If we then remove our print, if we were to run this, in theory, it would just add all of the column names to this column names list. And we can do a sort of sanity check by outputting the length of column names with len, L-E-N. So we expect this to have a length of 35 when we are finished. After this for loop is run, we expect the length of column names to be 35. That's how many columns there are. So look at that, 35, bang on. So we are in good shape with respect to column names. We now revert back to the player data. So we will say player data df gets. So now we need a way to get all of the data in that original data frame except for the first two rows. We used df.head to get the first two rows, and fortunately there is a partner function to head, which is tail. So we would be using df.tail, some number of rows in there, to get the player data df. If you would like, you can take a crack at thinking about what we might want to put in here. Obviously, you can just, well, I won't say obviously anything. You could put a number. You could figure out the number to plug right in here. There, you have the means of figuring that out. You could also figure out a way to do it algorithmically. We have a way to determine the length of df and a way to determine the length of the column names df. You could do this without having to put in a number. So if you'd like to, you can take a second to take a crack at that. Otherwise, I'm going to do df.tail length of df minus length of column names df. And this will give us 622 rows. It excludes the first two with the column name rows and gives us everything else. Length of column names df is 2. The full df is 624. And just to prove that, 624. So one thing to observe immediately, just visually assessing the data, is that there's this league average row. We don't want that. So we can do, there's a couple ways of doing this, but we will do player data df. We could do .head 621. That's one way. A lot of ways to skin a cat. We will do .drop, and then I think we want axis gets 1 620. That doesn't feel right. Let's try it. Let's try it and see what happens. Right. I'm stupid. So when you're using a keyword argument like axis is in this scenario, axis gets, that's a keyword argument. That has to go after what are called positional arguments. Python is able to infer what you're trying to do based on what you plug in where. So we are trying to put in this index, but we didn't tell it that. We are expecting it to infer that. So that has to go first. Now when I run it, I broke it. 623 not found in axis. So it is axis get 0. We probably don't need that argument then. Yeah, we don't need that argument. Axis get 0 is the default. So this dropped, or rather this is showing us the data frame after dropping this 623 as the index. What it did not do though is reassign the value of the data frame. This is only showing us what the data frame looks like once that function is applied. If I remove that function and then run it, that league average is still there. So there's two things we can do here. We can add this argument in place equals true. What that will do is it will not display the data. It will instead modify the data. Then if you were to use that data frame in the future, it would not have the league average row. The other thing that we can do is just reassign the data, the player data df variable to be pointing to, or rather, I should not use that terminology, to be the original data frame after having dropped that 623rd index. So we are going to go that route. So now it no longer has that 623rd row when we print it. And we can even make our notebook a little cleaner by cutting that and then dropping it in here. And so now we have just player data in this player data df, which perfect. That's exactly what we want. We now want to assign those column names to the player data df. That is pretty straightforward. Player data df.columns gets, what did we call it? Column names. And then if I go player data df, so look at that. Now we have our player data with appropriate column names. So we are cruising. A good next step would be to remove the columns that don't have fantasy relevance. So obviously we are going to want yards, touchdowns, receptions. I think targets is probably appropriate as well, but we aren't going to necessarily need, for example, rate measurements. So we can output the column names, which remember we can do with column names. We could also do with player data df.columns. A lot of ways to skin the cat. We are going to look at these and say, what do we want? I'll copy the whole thing. We will call it keep columns or keep calls. Paste it in there. Don't need that one. I don't need awards. Fumbles is technically relevant to fantasy scoring, but I don't know. The point here is not that I'm trying to prove to you that I can make accurate fantasy calculations. The point here is to show you how to do certain kinds of manipulations. So for the sake of simplicity, I am going to leave off fumbles. Scrimmage RTD we do want. Yard screen we do want. We don't need yards per touch, but touch is fine. We don't need most of this rushing data. Technically, we don't need rushing or receiving yards or touchdowns if we have that information in the scrimmage yards and touchdowns, but I will keep it just because in theory, a person might find that information beneficial. So rushing attempts is fine. Receiving touchdowns is good. Receiving yards is good. Receptions is good. Targets is probably good. I don't need games started, but games make sense. Position, team, age, player, rank. I don't think we need rank either. So these are our keep columns, and we can make them a little nicer to look at. Hate that, actually. Okay, that is better. So we're going to want to set player data df to be just these columns. And that is done kind of similarly. Earlier, we were using, up in this for loop, we were using this open bracket, column name, close bracket, and that's how we selected specific columns. So we were only passing in one column name at a time, getting just the values in that column. What we can do instead is pass in a list of column names, and it will give us all of the values for all of those columns. So it will give us that same data frame with just those columns. And that's great, right? Like, this is a much more concise, less visually busy set of data. Remember, we have not reassigned it yet. We have only displayed it. So to reassign it, then we'll just output the head. So awesome. We are making great progress. The next thing that we need to take care of, and it is something that is easy to miss, and it is a good reason to inspect data. So we output the data, but what if we maybe, I don't know. What if we wanted to look at more rows? Well, if I want to look at 100 rows, for example, it won't let me, right? It does this little abbreviation thing with the ... That is a pandas configurable setting. So you will go pd.setOption, and then in quotes, display.max rows. Set it to whatever you want. I'm gonna set it to 100 because that's how many I want to see. So we look at the top 100 rows in our data set, just the first 100 sorted. And if we scroll through it, I'm looking for something specific that might not be here. Yep, okay, look at this. We have 3 rows for Davante Adams. One for his time on the Raiders, one for his time on the Jets, and then one representing the aggregation of his stats for each team. This obviously creates some funkiness in our data set, right? Davante Adams should not be on this list 3 times. So that is a good example of a time that it wouldn't make sense to review this, to review data visually. To solve this, we need to be cognizant of the fact that Davante Adams is not the only player to have played on multiple teams this season. We're going to want a list of all of the players that did that before we can move forward. And Pandas comes with a great tool for this situation. So if we do player data df and we just get the player column, we can do a .value_counts. What this is going to do is it will print each unique name or each unique value in the column and the number of times that value appears. Look at that. Deontay Johnson played on 4 fucking teams this season. Is that real? Who did Deontay Johnson play for? The Ravens? The Texans? The Panthers? Was he on the Steelers this season? Was he on the Browns? I feel like I have to look this up before I can. Actually, it'd be way easier to just. I don't feel like that's Deontay. Houston. Oh, right. I'm stupid. Okay, he only played for 3 teams. He had 4 instances in the data because the 4th is the aggregation row. I was literally just telling you how this works, and then I immediately fucking forgot it. We come back to our notebook, and our pride is kind of wounded because we forgot about the multi-team row. And we see that these are our list of players who are kind of creating a problem in our data set. So I think a good path forward is to get our list of players who are only on one team throughout the season. That is most of the players. And then our list of players who are on multiple teams throughout the season. Have them as different data frames. These single team players we can sort of set aside. That's not one that we need to work with. The multi-team players, we will just get the rows that have the aggregated data. Then we can take that set of rows, combine it with the single team data frame, and we will have a good, clean set of data with 1 row per player. If that didn't make sense, I'm sorry, just follow along. So I'll take these value counts and I will do, I kind of want the same thing, but I want it where the number is greater than 1, right? And in fact, what I'm going to do is I'm going to set value counts gets value counts, right? And then I will do VC where VC is greater than 1. This is going to drop all of the rows where the count is only 1, or in theory any row where is 0 or anything below 0, but our data set only has values between 1 and 4, so it's going to drop everything that is not anyone who didn't play on multiple teams basically will not show up in this data set. So right, this is our list of players that played on multiple teams this season. Deontay is the only one who played on 3 teams. So we want to get just the player names. We can do that by tacking on player. If you look, this is a column name. We can't do that. We can't actually do that. It's because it's not a column name. It's the name of the series. Essentially, each column in a data frame is what is called a series. Series don't have column names. They only have column names when they are a column in a data frame. When they are not, they are just a series, and their name is called an index. So now we have the index of this series, which is the list of players that have more than one team played for. We can now, we'll assign that to a variable just to make it easier to work with. Multi-team players gets, and then we will do multi-team players df gets player data df. And so what I'm about to do, I don't find this syntax intuitive at all. This is one of the many, many, many reasons that I don't use pandas as a matter of preference. I use polars. I find it to be much more intuitive. And filtering data is one of those reasons. What we're about to do is filter for only these players. And the syntax is just kind of bizarre for it. So I get what it's saying, but just naturally, like as a matter of intuition, it is not straightforward. So we're doing player data df, open square bracket, player data df, open square bracket. Then inside of that second, that nested square bracket, we will put player, which is the name of the column that we are wanting to compare, equals. So not two equals, or not, let me try again. Two equal signs. One equal sign is gets, two equal signs is equals. Player data df player equals, yeah, that was wrong. What we want is player data df player dot is in multi-team players. What this is saying is this highlighted portion here is kind of like the rows where the player column is one of the values in the multi-team players index. We can call it a list. It's not a list, but we'll call it a list. And then by plugging it into these square brackets, it's essentially saying get the player data df where this is the case. If, for example, I'm going to comment this out by just hitting Control/, and then if I just copy this part and print it, it's going to give you a list of trues and falses, right? It'll be false anywhere that the player is not in the multi-team players. It will be true anywhere that player is a multi-team player. So by plugging it into that bracket, it's going to give you only the rows where this value is true. It's going to drop all the falses. Oh, I put mullet. And you know what? It might actually help with your intuition if I do this. So remember, this is the trues and falses. If I then do value counts, we have 581 false, 40 true. Okay. So when I plug this series of trues and falses into this player data df to only get those rows, how many rows should this return? All right, you've had time. I'm going to now answer it, which is 40. This multi-team players df should have 40 rows. And because we adjusted how many rows are being printed, this is not telling us exactly how many rows there are in this multi-team players df. So I'm just going to edit that a little bit to give the length, which is 40. I'm also going to revert our changes to the max rows displayed back to, I think default is 10. So I will set it back to 10. That way when I print multi-team players df, it will once again at the bottom say 40 rows, 15 columns. Great. So we now have every row for a player that played for multiple teams this season. What we want is only the rows that have the aggregated stats, right? I don't need to know how Davante played on the Raiders or the Jets. For the purposes of fantasy calculations, what I care about is how he played for both teams combined. So there's a couple ways to do this, right? And I've said that a bunch of times. There's a lot of ways to skin a cat. Fortunately, we can take the easy route here because the data that we are presented with here is compatible with the easy route. We can just do multi-team players df, and then kind of saying where, like when you use that square bracket, you're kind of saying where, like multi-team players df where multi-team players df team. And what we want to do is say, get every row where this team column has TM in it, right? We could say, get every row where it is 2 TM or 3 TM. But if someone played for 4 teams, you would need to have 4 TM. So it makes more sense to be kind of number agnostic and just say, if it has TM in it, that's perfect. Now, if, for example, there were a team in, I don't know, a city where TM could theoretically be in the abbreviation. So Obviously, this is very important. And we will ask our almighty robot overlord for an example. So I'll say, what are some cities that could be abbreviated to 3 letters in a way that includes TM? And our almighty robot overlord, Tamako, Atmore, St. Michael. Oh yeah, I feel like that's a good one. Tampico. Yeah, that ain't it, but we'll go with St. Michael. If St. Michael, Alaska ever gets a team, this pattern will no longer work because TM will no longer be a reliable indicator of a row featuring aggregated data. Their abbreviation would presumably be STM. So if you look for just TM, those rows would come up as well, which would be a problem. In that situation, we would be using what are called regular expressions. They are kind of a complicated headache that no developer ever wants to work with. Just kind of a horrible thing that we all accept as part of our profession. Fortunately for you, me, us, we don't have to do that right now. We can do it the easy way. So wipe regular expressions from your brain. Don't think about them for as long as you possibly can, because one day you will learn them and your life will be worse from that point forward. So again, we are looking for any team name that contains TM. And to do this, we are doing multi-team players df team dot str dot contains. This is essentially saying the string of the values, if it contains TM, we're going to get a true. So when I look at just that data, look at this here. Now we have just rows with TM in them. So 13 rows, there are 13 players that played for multiple teams this season. We can append this to our single team player data frame to have a full, clean, 1 row per player data frame. So did we create that data frame already? I forget. I don't believe that we did. So first we'll create that single team player data frame. Single team player df gets player data df. And let's go refer to how we created the multi-team players df. And we're actually going to copy it. So look, we did player data df player dot is in multi-team players. What we can do now is just the opposite, right? By using a tilde, we will just say not this, the opposite of this, right? Just get us the data that is not this way. I don't know how else to make it clear that it's just the other way around. But if we look at the output of this, right, 581 rows. And if we do value counts on the list of players, every single entry on the value counts list will have a value of 1. So every single player on this list only played for 1 team. That's great. Now, what we want to do is combine those 2 data frames. So first, I suppose I should observe that this was not reassigned. So we're going to want to do that just to ensure that we can join the data together. Now, what I'm going to do is I'm going to put player dfs gets, I'm going to create a list. Remember, we talked about this being one of the ways to create a list, but I'm not going to create it empty. I'm going to put in it single team player DF, comma, multi-team. And I think I did not use the same naming convention each time because this is single team, singular. This is, wait, multi-team players, single team player. So yeah, single team player, multi-team players. I use a different naming convention each time. That's all. Very bad practice. Even if you're only working on projects by yourself, even if you don't have a team that needs to understand your code, you eventually will need to understand your own code. That is bad practice. So now I've got this list of data frames, and the length of it, or sorry, no, I'm not sorry for anything. I'm right. I have this list of data frames. The length of it is going to be 2. When I print that out, see, we now want to do what is called a concatenation. Just joining them together. So once again, PD is our source for that. PD.concat is the function, and we will just throw that list in here. That's going to give us 594 rows, right? The 13 multi-team players and the 581 single team players. So this is our full, clean, 1 row per player data set. Now, before we calculate how many points each player had last season, by visually inspecting the data again, we can recognize another, I don't know, I wouldn't say problem necessarily, but an inconsistency between what we are looking for and what the data currently represents. So we see we have quarterback Tim Boyle represented in this data set, but if we are trying to calculate fantasy points based on yards from scrimmage, then we almost certainly do not care about quarterbacks. Obviously, quarterbacks are eligible for yards from scrimmage points, but if we are calculating specifically yards from scrimmage points, I can't really think of a context in which we would want quarterbacks to be included in that data set. So we are going to drop quarterbacks from the data, but we should also investigate what other positions are present here, right? Like, remember that season where JJ Watt was catching touchdowns? Like, he would show up in this data set if that had happened this year. So I will assign player DF gets that concatenated value. And then I will do, so I want to know what positions are here. And we do have a tool, right? I have already used a tool that we're going to use here. You can take a second to think about it, review the code. Otherwise, I'm just going to go ahead and do it, which player DF position, or I guess just POS dot value counts. This is just going to tell us every unique position in here and how many. So as you can see, it is longer. It has 20 rows, so it's longer than we can display. So that's what I get for changing that display option back to default. I'll set it to 20. So this is interesting. Obviously, wide receiver, running back, tight end are all interesting to us. Fullback, I don't know. It technically counts. Is there a single fullback that was anything? I mean, is there a single fullback that had more than 10 fantasy points this season? Right? Player DF, where player DF position equals. Oh, okay. 6. Right. Juice. Obviously, Juice would have had more than 10 fantasy points. Ingold had, I don't know, 15-ish. Okay, so yeah, Juice, unfortunately, not fantasy relevant. Everyone wishes. But I think for the sake of what we're doing here, we can exclude fullbacks. Quarterback, we are going to exclude. We have a fullback D-line. Who's that? Scott Matlock. Huh. That's not what I expected. I don't know what I expected, but that ain't it. Okay, so Scott Matlock is our fullback D-line. Obviously, none of these positions are positions that we want included in our data. Really, we just want the wide receiver, running back, tight end. We can do that by dropping any player that is in any of these rows. But the much more straightforward way of doing this is to just say, so we've got our keep positions. We will call them. Then we're just going to say, give me the data frame where position is in, as we used earlier, keep position. So we'll print that, and that drops, almost 100 rows. 100 and 4, 5? I can't remember what we had before. Anyway, this is now just going to be running backs, wide receivers, tight ends, which is precisely what we would want in this scenario. And we can reassign this so that we can use it moving forward. So that player DF. I think we are at the point where all we need to do is calculations. So our points, we will again use this square bracket syntax, but this time we are not accessing values in a column. We're actually assigning values to the column. So it's going to go on the left side of the equal sign this time. Player DF points gets, and we're going to do player DF receiving yards. Oh wait, no, we have scrimmage data. Scrimmage Y SCM. It is case sensitive divided by 10, and that is, it is your 1 point per 10 yards, rushing or receiving. Just don't want the different framing to confuse anyone. Then we'll do plus player DF scrimmage RRTD, rushing or receiving touchdown, times 6, plus, obviously, we are going to include the correct value for points per reception, which obviously anyone who has half a brain knows the correct answer here, which is receiving rec times 0.5. And look at that, my head is almost cutting off. That would have been so dramatic if my head would have cut it off and you wouldn't have known what I put in there. But that is the correct answer. So then if we output that player DF, we'll see that I broke something. Okay, yeah, sure. So what it's trying to do is it's trying to perform an arithmetic operation on or between a string and an integer. I would infer, I guess I would infer that these columns are each strings, but that's an easy fix, right? We used that as type syntax earlier to turn something into a string. You can try it again here if what we want to do is turn them into integers. Otherwise, I will fire away. And this line's getting very long. It often makes sense to do multi-step operations to reduce line length. I'm not doing that here because I'm lazy. All right, so I just converted all those to integers. The operations then worked just fine. So now we see this right-hand column is points, right? How many points a player scored last season. And then we can do, I don't know. Because what we care about, in this context is likely who is scoring the most and who's scoring more than whom. So player DF points dot sort values is how we would sort by any given column. In this case, we would sort by points, but I am stupid. We do not want to put in square bracket there points. We want to sort the whole data frame by points. And it goes in the opposite order. of what I wanted. Ascending gets false. Right, awesome, cool. So we now have a sorted list of players from most to least based on how many fantasy points they scored last season. Devastating to see Justin Ross down here at 0. That dude was going to be an all-time legend. If we compare this list to this season's fantasy leaders, or I guess I suppose I should say last season's at this point, now that training camp has started, we will observe that the point totals are not perfectly matching. Again, I excluded fumbles. Obviously, I didn't go looking for 2-point conversion attempts. Anything outside of yardage and touchdowns and receptions did not get included in this data. So there will be some aberrations, but for the most part, they will match. But 322 for Barkley, 317 for Henry. And I don't know if this is, what is this? Is this? I don't know what format that is, but I have 334 for Barkley, 328 for Henry. I have 338 for Gibbs. What do they have for Gibbs? 311. Why? Receptions 52. So if I take 311 plus 26, 337, which is, I don't know, basically exactly what I have. So it looks like this is just non-PPR. Is that what's going on? If I take Saquon, who had 33 catches. No, that's not what's going on here. Because if that were true, I would have 350 for Saquon. What the hell is happening? Is this some weirdness related to the fact that I use the scrimmage information? If I do rushing points, and then receiving points, and you just hit Control C, Control V, and that will copy and paste a line. You don't have to highlight it. And then I do reception points. I see the, I am just going to go non-abbreviation because I had created confusion using the abbreviations. I'm just going to divide by 2. Pallier. Yeah, that's not what it's called, is it? So now if I go look at I guess I could combine them. Oh, right, reception points. Oh, gee. No, that's the same number. What weirdness did I do here? I'm gonna go back to where player DF gets assigned, and I am going to remove. I'm missing something, and I know it's something stupid. It's late, and then I'm gonna sort. I guess I should sort it. I don't need that one, but I do need this to be ascending false. Oh shit, it was assigned previously. Okay. So I'm going to combine them all into one data frame. There we go. So now all of these player DF calculations, modifications end up in the same cell and make it a little more readable. So now I have 319 for Henry, 318 for Saquon. So that is fine because of, 2-point conversions and shit. I think it's fair to have them neck and neck. Where's Gibbs? Here's what I'm curious about. 311. Wait, am I just dumb? Did I have the right number the whole time? I think I did. That's going to be so embarrassing if I did. Oops, right. $339.5, $338.9. Okay, so I only care about the running backs. $338.9, $334.8. This is full PPR. Oh my God. They're close enough that it's clear that the difference in points is like the 2-point conversions and fumbles and just other potpourri ass points. Henry at 326, Bijan at 311, Henry 328, yeah, Bijan at 309. Okay, yep, that's what I did. That's exactly what happened. Jamar should be around 340, 330. Oh my God. Yeah, so I had the right number the whole time. Went on that goose chase for nothing. That is pretty much it. Let's look at what we did. Obviously, we installed Python. We learned a little bit about notebooks, about what data frames are, how to read a CSV into them. We used for loop to do some string manipulation. We did some data frame manipulations to get head and tail. We reassigned column names. We filtered out certain columns, or I guess we selected certain columns that we wanted to keep. We did some kind of complicated stuff here with respect to, these multi-team player things and identifying them and selecting them from the data frame. We filtered out, just the aggregated data, or rather filtered in. We cleaned up data with some data that was already clean. We did some arithmetic calculations. That ended us with, a good, interesting sort of, I wouldn't say the data itself is interesting. You can get it on any fantasy site, but the process that we took to get there it's interesting. So that is then the resolution to this video. Like I said at the beginning of the video, everything that we did here is foundational. So though we did not net anything novel, you do now have a lot of the skills that will be necessary moving forward when we do start to look at more novel analysis and in looking at creating things that others haven't already created, and about generating value that the rest of your league mates don't have access to. So good work and good job. How do I sign off? So subscribe, come back for the next video, watch it, do the things in that video as well. It will make you a better person, probably.